Hi, welcome to this video short where I will do an example of evaluating the limit, specifically the limit as x goes to 2 of x squared plus 2x minus 8 divided by x minus 2. Now before you get wild and crazy with the mathematics, I recommend that you first substitute the number that x goes to into the function to see what you obtain. So in this example, we will substitute 2 into our expression, we will evaluate that expression, and lo and behold, we get an answer. Now this answer is even a cool answer. It's 0 over 0, which is indeterminate. All that means is this is a job for algebra to take us to the answer. Now, if you had received an answer, a number like 2 or pi or 12 over 14 or even 0, you are done. Remember, 0 over any number, except 0, of course, is equal to 0, and that is a valid answer. While any number, again except for 0, over 0 is undefined, and we cannot solve that problem. But for us, we have an indeterminate value, and we will use algebra to help us. Just a reminder, other forms of indeterminates are, of course, 0 over 0, 0 times infinity, infinity divided by infinity, infinity minus infinity, 0 to the 0, infinity to the 0, and even the strange 1 to the infinity. So let's go and actually solve our limit problem. Now, I like looking for clues. Now, one of the best clues that you have is the value that x goes to. You can treat the arrow like an equal sign. And when you do that, we can pull the 2 across. And x goes to 2 is equivalent to x minus 2 goes to 0. There's the hint. Because we had 0 divided by 0, which was indeterminate, if we can cancel out that 0 over 0, what we have remaining is a simplified version of our original expression. And we should be able to plug in our numbers as x goes to 2, plug in 2, and we should be able to obtain an answer. So what we would like to do is cancel out an x minus 2 from both the numerator and the denominator. Lucky for us, we have an x minus 2 in the denominator, therefore there should be an x minus 2 somehow hidden in the numerator. So if you factor the numerator, which is a good thing to do, this is where your algebra helps you, we'll notice that we actually get an x minus 2 over x minus 2. They will cancel out, giving us the expression x plus 4. Therefore, the original expression is equivalent to the limit as x goes to 2 of x plus 4. Substitute 2 into our expression and see what we get. We got a number, the number 6. We are in fact done. That is the limit of the original expression. Now, I just want to talk about the simplified version, x plus 4, compared to the original expression, x squared plus 2x minus 8 over x minus 2. These two expressions, if we graph them, you'll see exactly what we did. So I'll bring both of them down. Now, the simplified version is on our left. And you'll notice that as x goes to 2, I get the value 6. In fact, it's a very easy, simple line. It is continuous, and there is actually a point at 2, which is 6, which is in fact our limit. In the original expression, we actually have the same graph, except we have a hole at the x equals 2 location. But if you notice, the graph still approaches the 6. The y value of the function approaches 6 from both sides. And that is the requirement for a limit. We don't care if there's a point there or not. We just want to ensure that as x goes to 2, the y value goes to some expression from either side as x goes to 2. When we simplified it, we were able to get an expression where we just had to plug in 2 to get the answer. Thank you.